This lesson is on solving systems of nonlinear equations involving conic sections. This is more advanced techniques than the first time we did a lesson on this. Let's solve the following system of equations. X minus 2 squared plus y squared over 4 equals 1, and x equals y squared over 3. So the first one is an ellipse, and the second one is a parabola. What I would probably do is take the second one and turn it into y squared equals 3x. Take this 3x and put it where the y squared was. So we have x minus 2 squared plus 3x over 4 equals 1. X squared minus 4x plus 4 plus 3x over 4 equals 1. Most of you will probably not want to have fractions in this, so let's multiply the entire thing by 4. And then finish by getting everything on the same side. So we have 4x squared minus 13x plus 12 equals 0. So we combined like terms and added or subtracted 4 from both sides. Now this looks like we might want to factor it, but it's not factorable. So let's use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, when we do this, we end up with x equals 13 plus or minus the square root of negative 23 over 8. That clearly would be an imaginary answer, so therefore there would be no solutions on the coordinate plane for these two equations. Not every time you use the quadratic formula are you going to get no solution. Sometimes you're going to get solutions, they're just not so nice. But I did want to include something that did have no solution just to make sure that we are aware that that is something that can happen. And so if we take a look at the ellipse and the parabola that we graphed, what we see is there's no intersection point between the ellipse and the parabola. Therefore, no solution. Second problem. Solve the following system of equations. Okay, why would we have to do something like this? This is much harder. Well, the reason is you're in Honors Algebra 2 Trig, and therefore you have to be able to do things like complete the square in order to solve these types of problems. So what I would probably do is I would write the top one as 2 times x squared plus 2x plus blank, and then minus 4 times y squared minus 4y plus blank, and that equals 22. That really was not that nice. I don't know why it broke into all these parts, but such is life. So when we do the completing the square part, and hopefully everybody knows where everything came from, I just factored a 2 out of the first 2 terms of the x, and then I factored a negative 4 out of the first 2 terms of the y, and then we're going to figure out what the other term is. So 2, we divide 2x, the 2 gets divided by 2, so it's x plus 1 squared, and 1 squared is 1. Now remember that that 1 is getting multiplied by 2, so that means that when we add a number to the other side to keep it balanced, we're adding 2, we're not adding just 1. Likewise, it's minus 4y minus 2 squared, and remember it's 4 times the negative 4 that's out here, so we're actually subtracting 16 to the other side. 22 plus 2 minus 16 is 8. So I've now completed the square. And so now what I'm going to do is I'm going to look at these two problems, or look at these two equations. We have 2x plus 1 squared minus 4y minus 2 squared equals 8. And then what I'm going to do is I'm going to look at the bottom one, and I'm actually going to add the 8y minus 2 squared over to the left. So in this problem, I'm going to throw in a bunch of techniques that you're just maybe going to see only once. Maybe you'll never use them. Maybe these are things that you might be able to use relatively, I wouldn't say frequently, but with a whole lot of success. And the reason why I think this is beneficial is if you take a look at this, there's a negative 4x or y minus 2 squared and an 8y minus 2 squared in both of these equations. What that actually will do for us, we can eliminate the entire term y minus 2. So if I multiply the top equation by 2, I can actually eliminate the entire term of y minus 2 from this problem. So I have 4 times x plus 1 squared plus x, the negative 8y minus 2 squared and positive 8y minus 2 squared, they they add together to be 0, so they go away. And then there's a 17 on the other side. Now, I could distribute the x plus 1 times x plus 1 and then get everything on one side and see if I can factor, and I actually can. So I'll do that really quick on this side. And I mean really quick, I'm going to do it because I want to show you another technique. So x minus 1 and 4x minus 13 ends up making this work. So x equals 1 and x equals, I'm sorry, this should be a plus. X equals negative 13 fourths would be the two answers. You can get that. I'm not saying not to do it, and as a matter of fact, in this problem, it might be the easiest. But I want to show you another technique that might help you in the future. So if I take a look at 4 times x plus 1 squared, if I write this as x plus 1, so let's say I add an x plus 1 to this particular problem, or I add 1 to both sides, and I make it so that there's an x plus 1 squared and an x plus 1. What I can do is I can take x plus 1 and set it equal to some other kind of dummy variable. So I'm making a substitution. I'm using u or some other variable as a way to substitute in for x plus 1. So I can replace x plus 1 with u. Now, the reason to do this would be, let's say, inside the parentheses, you had 7x plus 9, and it's going to end up being a really ridiculous factoring after you end up doing all this stuff. If you have a substitution, you can actually make this pretty easy. So we can factor this into 4u plus 9 and u minus 2. Now remember, we have to solve for x. We can't solve for u. But if we get u equals negative 9 fourths and u equals 2, and then we take those and substitute them back in to u, all we would have to do is subtract 1 from both sides and get x. And guess what that gets us? It gets us what we would have got if we just did x all by itself anyway. So I'm not saying that what I just wrote in red is something that's required. You can do every single problem this way, But some more complicated problems, it might be a whole lot easier to make a substitution. And when you get to calculus, that's something that you're going to have to do in order to be able to integrate certain things. So that's just kind of a preview for something that'll help you down the road. Okay, so in this problem, we got x equals 1 and x equals negative 13 fourths. And then we would want to substitute these back in. Um, so I'd probably take this equation um, or this equation, either one, but that ends up being something that's a little bit easier to work with and manipulate. So if x equals 1, we have 0 equals negative 8 y minus 2 squared. That's what happens after you subtract 1 from both sides. So clearly y would have to equal 2 in that case, because the only way that that would equal 0 is if y equals 2. So there's one solution when x equals 1. Remember that for when we get to the graph. There's one solution for when y equals 1, or when x equals 1. It is 1 comma 2. Now if I take negative 13 fourths and plug it back in, well, this is a little bit nastier. Negative 13 fourths equals negative 8 y minus 2 squared plus 1. If I subtract the 1, that's going to be negative 17 fourths. And I divide by negative 8, I get positive 17 over 32. I would have to square root both sides. And I mean, in the interest of time, I'm not going to finally solve for y. But notice that we're going to get two different answers for y here. So when x is negative 13 fourths, y will equal plus or minus, and I'm not going to reduce anything just to be in the interest of time here. But y equals 2 plus or minus the square root of 17/32, which is clearly not that fun to look at. But we have negative 13 fourths, comma 2 plus root 17 over 32, and negative 13 fourths minus root 17 over 32. So to summarize, our final answers for this would be 1, 2, and negative 13 fourths 2 plus root 17/32. Again, you would have to simplify that. And negative 13 fourths 2 minus root 17/32. So we should have three answers for this problem. When we go to Desmos and graph it, we end up with those three answers. So notice this is one of the cases where the parabola just barely intersects. It glances. It just touches that hyperbola part once, and then the other two kind of go on over there. So it's negative 13 fourths for the x, and then that nasty thing for the y. So that is that, and I hope you have a good day.